Now for section 6, we have inequalities in one triangle. So we're going to talk about what information I can conclude based on one triangle and how I can find the missing sides of my triangle and determine if the sides that they are given are possible values that could be the lengths of my triangle. So for the first part here, we're identifying the largest and smallest angles and the longest and shortest sides. So you want to make sure that you read your directions. Notice that I circled angles here and I circled sides here. That way I know what part I'm looking for. So here I'm looking for angles, which is the largest. So the largest angle is going to be across from the largest side. So notice that 7 is the greatest value between 7, 4, and 6. It's the biggest, so that tells me that angle E is my greatest angle. 4 is the smallest number, so that tells me angle F is the smallest angle. Problem number 4, 10 is the greatest value, so that tells me angle C is the largest. 5 is the smallest value, so angle B is the smallest angle. When you get to problem number 5, it's asking for the longest and the shortest side, using the same type of technique that I did for 2, but now I'm looking at the angle measurements. So notice that I have angle measurement here of 130, angle measurement here of 15. So now I need to figure out what the measurement is of angle F so I can determine which is the longest and shortest side. So I'm going to take 180 minus 130 because all of the angles have to add up to be 130. All the angles have to add up to be 180. They already gave me 130, so I'm going to subtract. They left me with 50. Then I'm going to subtract 15. That leaves me with 35. So the measure of this angle here is 35 degrees. So 15 is my smallest angle. So that means that side EF is going to be my smallest. So EF is the smallest. Notice that my side has 2 letters and a line on top to show that it's a line segment. My largest side or longest side is going to be across from angle 130 because it's the greatest angle measurement. So I'm going to write that as DF with a line over top. Problem number 7, I'm doing the same thing. All of my angles add up to 180. I'm going to subtract 100. That leaves me with 80. 80 minus 35 leaves me with 45. So I know the measure of this angle here is 45 degrees. So my longest side is going to be SV because it's across from 180. My shortest side is going to be ST because it's across from angle 35. Now, on the back side, it's asking us to determine if these can be the lengths of our sides. So notice I made some notes. For 8, 9, and 10, I have all 3 of my sides. Notice they listed them there. And then for 11 and 12, I don't have the measurements of those sides. So what I'm going to do for 8, you can see here I've already done it. I made my 3 inequalities based on the sides that they gave me, 2, 3, and 7. So 2 plus 3 is greater than 7, 3 plus 7 is greater than 2, 2 plus 7 is greater than 3. Notice that all of these values on the end here need to be different. That's how you know you set up your inequality correctly. So I'm going to go through and check to see are my inequalities true. Is 2 plus 3 greater than 7? No, it is not. So my answer to that would be no. These cannot be my lengths. If one of my inequalities does not work, my answer is automatically no. So notice for 9 and 10, I already worked these out. All of my inequalities hold true for 9 and 10. So my answer here is yes and yes. Now, for 11 and 12, I need to set up my inequalities, but this time I'm using x. So, for number 11, notice here I had 5 and 3. X is the number I don't know. So, 5 plus 3 is greater than x. 5 plus x is greater than 3. X plus 3 is greater than 5. So, then I'm going through. Notice that this is negative. I can't have a negative length, so therefore that one's not part of my solution. Here I solved for this one and this one, so x is less than 8, but x is greater than 2, so that is my solution.